Alright, in day 4 we are going to be solving right triangles. Now, previously we learned how to find the side lengths of a right triangle either using Pythagorean theorem or SohCahToa and those trigonomic functions on our calculator, but now we're going to talk about angles. So to solve a triangle, so if you ever see those directions, solve the triangle, it's to find the measure of all its sides and angles. And then to find angles, we can use the inverse trigonomic ratios. They are used to find angles. So basically, we're going to set up things the same way as we did previously with SohCahToa, sine, cosine, and tangent. But what's going to happen is that we're not going to know the angles, but we're going to know the two sides. And then we're going to use the inverse trig ratios. That's what that -1 means. That tan -1 means the inverse of tangent. On our calculators, you would press the second button and then the trig function you want to use. So to find the inverse sine, we would press second sine. So you will need a calculator for this. Now, this is the example 1 is just to get us in the mindset of figuring out how to do these on the calculator. So in order to find the measure of angle A when sine of A is 0.76, we would do the inverse sine of 0.76 in our calculators. So in our calculator, right, I got to make sure I'm in degree mode if I have a graphing calculator. And then I will do the inverse sine of 0.76. So that's 49.46 degrees. So A is 49.46 degrees, because the directions say the hundredth of a degree, so that's 2 decimal places. Example B, it says the cosine of B is 0.17, so we need to do the inverse cosine of 0.17, and B will equal inverse cosine of 0.17. We get 80.21 degrees. So you see that this isn't really too bad once you get down to this step. All right, then the last one, the inverse tangent of 0.8. So inverse tangent of 0.8, and that's 38.66 degrees. So A equals 38.66 degrees. So you have to know how to do this in the calculator. Like I said, once you get down to this part, it's not too bad. Alright, example number 2, we have to look at these side lengths as well now to figure out the angles. To solve the right triangles, round decimal answers to the nearest hundredth. So we have this right triangle where we know that CB is 16, BA is 20. We don't know the measure of angle C, and we don't know the measure of angle A. So what you want to do is, let's pick a starting point. Let's start with C. Okay, if C is our angle we're talking about, CA is our hypotenuse, BA is the opposite side, and CB is the adjacent. So I want to find angle C. So we're going to do the same thing we've done before, is write out SohCahToa. And if I'm looking at angle C, I know the opposite side, so I'm going to underline the O's. And I know the adjacent side, so I'm going to underline the A's. So I'm going to use tangent. Then on the calculator, I'm going to do tangent of, well, we don't know what angle C is, so angle C is equal to 20, the opposite side, over 16. Now to calculate that angle, I'm going to use the inverse tangent of 20 over 16. So inverse tangent of 20 over 16, I get 51.34. So C is equal to 51.34 degrees. Okay, so now that I know that angle, well, angle A I can figure out because all triangles have 180 degrees. Angle B is 90. Angle C up here is 51.34. So if I do 180 minus 90 minus 51.34, that will give me the measure of angle A. So 180 minus 90 minus 51.34, I get 38.66. So A equals 38.66. Now to figure out the hypotenuse, you could use SohCahToa, or since we have two side lengths, you could use Pythagorean theorem. It doesn't matter which one you want to do. However, if you're going to use SohCahToa, you have to make sure that you use a trig function where the hypotenuse is used. So that means you're going to use either sine or cosine. I'm going to use Pythagorean theorem. So 16 squared plus 20 squared equals c squared. And the reason why I'm using Pythagorean theorem is because I know that this one is a Pythagorean triple. At least I hope it's a Pythagorean triple. Let's find out. I think it is. So 16 squared is 256 plus 400 equals c squared. No, I think I'm wrong. I don't think this is a perfect square. $656 equals c squared, and then when I square root both sides, that will give me 25.61. Let's see, I've run out of room here. So side CA is equal to 25.61. I'll write smaller for the next problem. Alright, part B. We are given that one of the angles is 23. So all triangles add up to 180. So if I do 180 minus 90 minus 23, that will give me what that angle B is. So I'm doing that in the calculator. I get 67. So B equals 67 degrees. Now we got to find the other sides. Well, we have our angle 23 degrees, so I'm going to write out SohCahToa. And our opposite side is BC, our hypotenuse is BA, and AC is our adjacent. So I know my hypotenuse, so I'm going to underline the H's. Now, it doesn't matter which one you find first, either the opposite or, we have the opposite side and the adjacent side. We have to figure out both of them. So let's start with, I'll do the adjacent one first. So I'm going to underline my A's. So I'm going to use cosine. The cosine of 23 degrees is equal to x, we don't know what that side AC is, over 40. I'm going to multiply both sides by 40. And then in the calculator, I'm typing in 40 times the cosine of 23, and I get 36.82. 36.82 is equal to x. All right, that means AC is equal to 36.82. Now, to get this last side BC, you could use Pythagorean theorem, but because AC is a decimal, I'm going to choose not to. And now I'm going to use SohCahToa. I'm going to rewrite it again. You don't have to. Where I still know the hypotenuse, but I'm trying to find the opposite side this time. That means I'm going to use sine. So then the sine of 23 degrees equals the opposite, which we don't know what that is. I'm going to label it y since we already used x somewhere, over 40, our hypotenuse. Then multiply both sides by 40. So then in the calculator, 40 times the sine of 23, we get 15.63. So 15.63 equals y, and that tells us that side BC is equal to 15.63. So when you're asked to solve a triangle, remember, just take it one step at a time. Find missing angles, find missing sides. There were three separate problems in here. We had to find an angle, and we had to find two sides. Over here in the previous problem, we had to find, the two angles and one side. So we had to use the inverse trig function. In this case, we use the inverse tangent. Now, in example A, if you would have chosen A to start with instead, that would have been fine. All right, let's look at the next page. So you're building a track for a model train. You want the track to incline from the first level to the second level, 4 inches higher and 96 inches. Is the angle of elevation less than 3 degrees? So let's write out SohCahToa. There's a nice picture drawn for us. And our angle is right here. Our hypotenuse is up there. Opposite side is 4 inches. Our adjacent side is 96 inches. So I'm going to go back to SohCahToa and I'm going to underline my O's because I'm given the opposite side, and my A's because I'm given the adjacent side. So I'm going to use tangent. So the tangent of x is equal to the opposite side, 4 over 96. So then I will do the inverse tangent of 4 over 96. So inverse tangent of 4. And we get 2.39. So that's our angle, but remember the question is asking, is it less than 3 degrees? Yes, this is less than 3 degrees. Alright, now angle 4. Sorry, not angle 4. Example 4. A driveway that is 25 meters long is built on an incline. It has risen a distance of 4 meters by the time it reaches from one end to the other. What is the angle of elevation? So it says that it has risen 4 meters. So that means this is 4. And here's my angle. Let's write out SohCahToa. We are given the hypotenuse. I'm going to underline my H's. And let's see. This was the hypotenuse. This 4 does not touch our angle x, so this is the opposite side, which makes this the adjacent. So let's underline the O since we know the opposite side. That means we're going to use sine. So the sine of x degrees equals the opposite, 4, over the hypotenuse, 25. Then that leaves us with finding the inverse of 4 over 25. So inverse sine 4 over 25. 9.21 degrees. X equals 9.21 degrees. Alright, now for the last example. It says each step of a stairway rises 18 centimeters for a tread width of 32 centimeters. What angle does the stairway make with the floor? Okay, so let's look at this. Stairway rises 18 centimeters. So 18 for every 32 centimeters of width. Okay. So I go up 18 each time. 18. So I'm filling this out. So what I'm going to try to figure out is looking at this triangle, this right triangle. How far did I go up altogether? Well, I went up 18 here. Should be 18 here. And 18 there. So 18 plus 18 plus 18, or you could just do 18 times 3. You get 54. Then my distance left to right, 32, 32, 32, and that gives you 96. So I'm going to focus in on this right triangle. And my hypotenuse is up here. My opposite side does not touch the angle I'm asking about. And then this is my adjacent. So let's write out SohCahToa. And then underline our O's. And then the A's. And we get tangent. So the tangent of that little symbol, I probably should have talked about this earlier. This little symbol is another variable. The technical term is theta, but you don't need to know that. Just know that that means the angle measurement, and we're trying to find that. So if you want to write an x there instead, that's fine. So 54 over 96, which means we're going to do the inverse tangent of 54 over 96. And we get 29.38 degrees. So again, when you're finding angles, you use the inverse function for whichever trig function you're going to use, but you still write out SohCahToa and underline to figure out which one you're going to use. So, if you need to, replay the video, ask me questions, and I will see you guys tomorrow. Bye.